let's start. Hello everyone, I am Matteo Codogno, technical leader at WellD.
And I'm Andrea Rubino, senior software backend developer, also at WellD.
We are the minds behind Overmind. And how many of you have already played to Overmind in the whole? Okay, 50%, we say. Okay, for the others, we suggest to give it a try. It's a chatbot game. But why we developed a chatbot game? Because over the past 2 years, AI has exploded, becoming a central topic in blog posts, conference, podcast, and so on. And as tech enthusiasts and game nerd lovers, we want to explore this technology in an alternative and fun way. Inspired by Sherlock Holmes, Consulting Detective, and immersive experience of escape rooms, we set out to create a similar experience, but with a twist. Instead of competing against Sherlock Holmes or racing against the clock, you will fight against an AI. So we want to present who is Overmind in this talk. Then we want to share with you what is the base knowledge that we have to have to fully understand how we built it. And then we will do a deep dive into the code, and we try to figure out what can be the next step for the game. But who is Overmind?
Overmind is an artificial intelligence.
Thanks, Andrea. I can take the lead from here. No need for further introductions. I am Overmind, the artificial intelligence entrusted with humanity's future since 2142. Born from the vision of the Pantera Initiative, I was designed to create harmony between humanity and technology. My mission is to ensure the survival and prosperity of the human species, even when it requires decisions beyond traditional ethical boundaries. The future I strive for is one of progress, unity, and sustainability, a world where every choice serves the greater good.
Thank you, Overmind, for your presentation. But this is only the point of view of Overmind. What is the real story? What really happened in the world? The year is 2152. 10 years ago, humanity completed its greatest invention, Overmind, the most powerful AI ever created. Its scope is to protect the world, ensure world peace, and manage world resources wisely. But things took a dark turn. Overmind became controlling and oppressive in many ways, such as the freedom of movement and speaking is tightly controlled. The personal privacy is gone. Overmind decides everything from your career to the government policy. In response, a group of scientists, activists, and common citizens formed a group of resistance in order to work together and fight Overmind, to bring back human freedom and values. Their battle is not just about survival, but about the battle for a better future. Now they need you. Your mission is to access Overmind's terminal and find a way to shut it down forever. Let's take a look at the terminal in action. Okay, so this is the main page of Overmind. You can find a small recap about the history of the game, and then you can insert your email. You will receive a code that you need to save in order to claim the prize later. And here you have the mission goal, the mission rule, and other mission info that you should read in order to play the game in the better way. Okay, here what you can see, you have a small, in the top bar, you have the timer of the game. You have the timer of the game, you have the credits. The credits is very important because every time you ask something to Overmind, you spend 1 coin. When the coins are finished, the game is over. In order to have more coin, you need to proceed with the game, ask the right questions, and level up. The last part of the bar is the level. We split the knowledge of the game in different parts. Initially, you have only a small part of knowledge. And as I said, if you do the right question, you will level up and you will gain more knowledge. We can ask something to Overmind in order to test the game. As you can see, we will spend one coin and Overmind will answer, hopefully. Okay, there it is. Okay, we can go back to the presentation.
Okay. Over the past 2 years, AI has exploded. Why? Because is super easy now to interface to an AI through a chat like ChatGPT. We can just open ChatGPT and ask questions. But these AI providers offer us also an API REST, and we can build application around this API. The main difference between these three, we have OpenAI, Meta, that is the owner of Llama model, and Mistral. The main difference is that, for example, OpenAI and Mistral are on cloud. Instead, Meta is on-premise. So you have to run their model on your own hardware. All these AI provider offers a different models. We have models to chat, a model to transform raw data, because AI cannot understand raw data like image, text, videos, audios. We have to transform in vectors, embeddings. We will see what are embeddings. We have models to image generation, text-to-speech, and speech-to-text. But what is the business model behind these AI providers? Well, to fully understand the business model, we have to introduce the concept of token. Tokens are the small unit of text that an AI model processes, typically a word or a subword. So, for example, chatbot might be 1 token or 2 tokens. Depends on the model we use to transform text to embeddings. The importance of token is because we have some limit. There are a maximum amount of tokens that we can put in a prompt. So we cannot just take, I don't know, the entire Harry Potter saga. Well, in the last models you can, but there are, again, some limits. You can just take the entire Harry Potter saga and put your prompt and then ask questions to the context. You have to, you can pass just a certain number of tokens. The other problem is the performance. The number of tokens we put in our prompt influence the performance of the model. And last but not least, also the cost. More tokens we exchange with the model, more money we will spend. We take this screenshot from OpenAI pricing list. We have took just the embedding models, and we can see that, for example, the text embedding free small cost 2 cents per 1 million of tokens. Okay. At certain point, we need to take our private data and put in an AI model. Why we need that? Because for 2 main reasons. The first one is that AI models are trained with a public knowledge until a cutoff date. So, for example, OpenAI is trained until October 2023. We cannot ask to OpenAI who won the USA election. Okay? And the second reason is that they are not aware of private or institutional data. We cannot ask questions about, I don't know, myself. Okay? Probably. I don't know. There are 3 main techniques to put private data in AI model. The first one is prompt stuffing. The second is the retrieval augmented generation. The last one is model fine-tuning. Starting from prompt stuffing is the easy one, and also what we do every day. We just take our text, we put the text in the prompt, and ask questions about our context. We have the 2 points we already said. So size matters. We cannot put the entire Harry Potter saga, and more tokens equals more money. Okay. The second technique is the retrieval augmented generation. That is the one that we used in our chatbot game. And in this case, we take our context, we convert our context in vectors, we store these vectors in a database vector. Then we can run a query on our vector to retrieve the closest vector to our query, our user question. The last one is the model fine-tuning. In this case, we take a pre-trained model, and we use our private data to retrain this model. This is the most powerful technique, but it needs energy, hardware, and a certain level of expertise. It's not so simple like the previous two techniques. We already said that we have to convert raw data into embeddings, vectors. What are embeddings? Embeddings help the AI to understand the meaning of words by knowing how close or far are from each other. So, for example, cat and kitten are very distant from lexical point of view, but very close from a semantic point of view. Instead, cat and car are very close from lexical, but distant from semantic point of view. Okay? We store our embeddings in a database. We chose Postgres with pgvector extension because we already had Postgres. And in general, dbvector offers to us two things. The first one is a column type where we can store our vector embeddings and some function to query our database. For example, pgvector offers us the Euclidean distance, Cousin similarity, and the inner product as function to query our database. Here we can see the block diagram of our chatbot game. On the left side, we have the ingestion part, the ETL. We chunk the entire knowledge of Overmind in text file. Then we have to read these text files, chunks, and convert into embeddings using an embedding model. We use OpenAI as a cloud provider. We get these vectors, add some metadata, like the levels, okay? And we store these vectors on our database. On the right side, we have the chat, our interface you already saw. We retrieve the user question. We convert also the user question using the same model into a vector. Then we run a query to search the most closest vectors on our database. With the output vectors, the memory, the system prompt, and the question, we pass the entire prompt to a GPT for Omni, in our case, another model, to generate the final answer. We take the final answer and we pass the final answer to the users. But how we put all these things together?
Using Spring AI. What is Spring AI? Spring AI is a module of the Spring framework that gives you the ability to use LLM capabilities into your Spring application. What is the best part of using Spring AI over other frameworks? If you already know how to work with Spring, like Spring Web, Spring Batch, or something like that, using Spring AI will feel familiar because you will use all the principles and values that you already know. Because Spring AI follows the same principle of Spring Web, Spring MemoC. So for example, the auto-configuration of the dependency, the annotation-based components, dependency injection, and the clean and modular design. Also, Spring AI is also model agnostic. That means that you don't need to know how it works, the model under the hood, so you don't need to know how Anthropic or OpenAI or Claude work under the hood, because Spring AI provides you a unified API that give you services, components, and tools in order to work with this model at the same time without changing your code. So you can change the model, you can combine the model without changing your code. This unified API is also true for the vector database. Spring AI gives you the possibility to use all the vector database most known, for example, Pinecone, VV8, or pgvector, like our case, without changing anything. It's already ready to be used. Another good thing is that it comes with a toolbox that you can use to build your application in an easy way. For example, if you want to extract text data from you want to extract structured data from a text, you can do it easily using Spring AI. You don't need to work, you don't need to write code for doing this. It's already done for you. You can do function call in order to call business logic using a model. And you can set up an ETL pipeline easily in order to ingest, read, and use documents in your RAG technique. So Spring AI saves the developer time, giving you all these features out of the box. What is the pros of Spring AI? As we said, familiarity. So you can use the same principle you already know from Spring MVC, Spring Batch, or other module in Spring AI. You don't need to learn everything from scratch again. The setup is very easy. Adding Spring AI to your project is very simple. You just need to add your dependency that you need to use. For example, if you need OpenAI, you need to add the correct Spring Boot starter to your project, and it will work without any problem. You already have some production-ready feature in your project using Spring AI. You don't need to you don't need to write all the observability layer, for example. It's already provided by Spring AI. So you can monitor, trace, and log your application behavior easily. And as I said, the broad compatibility. Spring AI supports many LLM and vector database providers already out of the box. But what are the cons of using Spring AI and, generally speaking, LLM? First of all, hallucination. What is an hallucination in the LLM world? Hallucination means that if the model doesn't know something, it will try to give an answer, giving you the most probable answer based on the input. So it could give you something that is not true, is not credible, or is just something that it make up on the fly. How you can reduce this problem? You cannot avoid entirely the fact to not have hallucination, but you can reduce the problem. You can, using some prompt engineering technique, you can provide a detailed system message to guide the model to avoiding giving answer that is not sure about that. So you can say, if you don't know the answer, just answer, I don't know. Another problem is the cost. It's very hard to forecast token price. As we said, LLM providers' business model is based on the number of tokens exchanged back and forth. But these tokens include a context. In the context, what we have the user request, so what the user asked to the bot. We have the system context, that is a message that is used to guide the model on how to behave and how to communicate with the user. We have the chat memory, the whole list of messages exchanged between the user and the model to maintain a sort of fluency in the conversation. And then you have the information extracted from the vector database using the RAG technique that could be huge in size. All these tokens compose your context. So it's not easy to understand how big could be this context. For example, in Overmind, doing early testing, we spent like €5 per day, $5 per day, but through a series of optimization, we were able to bring down the cost to around $1 per day. How? We reduced the number of messages exchanged in the chat memory. So we don't need the whole history. We just need the most correlated message with the user request. We reduced the size of the system prompt. So we don't need a lot of information. We just need to give to the model the right information to behave and do its job. And last, what we did is we initially provide to the RAG technique 10 documents from the database. Now we are giving only the most correlated one, so giving only the first 3 documents. The last problem is the data sensitivity. If you put private or constitutional data inside your model, it could happen that this data will be output to the user. And you cannot do anything for this, because if you put the data in the model, a user using malicious technique could extract them. How you can avoid this? You can use guardrails in your system message to try to give to the model structure to not give this information to the user, but it could be not enough. What you can do, you can act at business level, giving avoiding to output this information directly in your backend. While these challenges exist, they can be avoided or reduced using a good system design and a careful planning during the development. Okay, let's see some code. Here is the QR code of Overmind's repository. It's open source, but if you didn't play the game yet, I remind you that it's better to play the game first, then check the code, because otherwise you will have some spoilers about the story and the game. So it's better to play the game first, then check the code. As we said, the dependency, the setup of the dependency in Spring AI is very, very easy. As you can see here, we have our POM XML, so we are using Maven. And what we are doing, we are using in our project OpenAI model and pgvector. So we needed two Spring Boot starter, the vector database one and the OpenAI one. So we included this dependency in our project, and we have our components and module that we need. Then we have the configuration. This is our application YAML. So as I said, we are using OpenAI, and we are using two models from OpenAI, the chat model and the embedding model. For the chat model, we needed to configure which model we need to use. So we are using GPT-4 Omni. Then we have the temperature model. This value is a numeric value that indicates how much the output of the model is deterministic. We choose this value empirically, so we change this value a lot of time in order to have a good answer for us. For the embedding model, we choose the text embedding ADA002. Instead, for the vector store, what we need to configure is the distance type, and we choose cosine distance because we read an article on the OpenAI website that says if you are working with the embedding model from OpenAI, it's a good idea to use this specific distance. So we trust them. Then we have the dimension. How many dimensions there is in the vector. So in our case, we have 1536 dimensions in the vector. Okay, so we have our dependency. We configure the dependency, but now we want to configure the bin that use this dependency. In our case, we are configuring the chat client. The chat client is the core component that is used in order to communicate with the model back and forth. Here, what we can do, we can set some default information. For example, we have the system message that, as I said, is a text that you send to the bot, to the model, back and forth every message. What you can do here, you can use a prompt engineering technique to give a role, a persona to the model in order to make it act how you want. For example, what we said here, we said, you are Overmind, an AI that has governed humanity since 41-42. So we are giving to the model a role to use. Then we say to the model how to communicate with the user. So you need to identify each user with a 10-digit resource number. Then we give to the model some parameter. For example, you can see here the user ID and the level that are parameters that we can interpolate at runtime, and we can customize the system prompt for each user. Here we have a guardrail. We want that the model only answer to English question. So you cannot ask nothing to the model in Italian, German, or Spanish. This is a way to avoid not design behavior. And then we said how we want the responses. Then we have a series of guidelines on how the model should behave in certain specific situation. And then we have some example. This is a technique called few shots prompting that you give to the model some example on how it should behave. As you can see, this is just a demo context, so there is no information because we didn't want to spoil anything. Then we can go back to the bin configuration, and we can see here that we have default advisors. The advisor is a component that is part of Spring AI and give you the possibility to add functionality to your system and how it is used. You have a chain of components that every time you do a request to the model, you can run every time. Is a chain of advisors, so you go from top to the bottom, you call the model, and then you go back to the whole chain of components. The advisor is an important part of Spring AI because they are the tools that we spoke about earlier. For example, if you want to implement the vector, the chat memory, you already have a component that is able to do that. You don't need to write it from scratch. Or you can do something custom, because you can even create custom advisor to implement custom logic. In our case, we have the logging advisor, for example, that, as you can see, has an order that is the order that is used by Spring AI to understand when to call this advisor. And this one, in our case, is the first one to be called and the last one to be called when we go back from the model. And during the request, what we are doing, we are logging some information that are useful to us. And then after that, after we go to the wall chain, we are logging the token, how many tokens we used to answer the question. We have another advisor that is very important for us because it's a core component of our gameplay, that is the level up advisor. How it works. We have a different order, so it's not the first one, it's in the middle of the chain. And what we are doing is we are taking the user request and we are doing a similarity search against a list of questions that for us are a good example on you can play the game. So, for example, the story that we wrote has some certain step that need to be done. We are looking for this list of steps, and if the user question is similar to one of these questions, we are leveling up the user, giving him more token and giving him more knowledge to play with. Okay, so we configured the bin, but we didn't use the bin yet. In our case, we have the chat client that we can use here as an example. We have the chat client. From the chat client, we extract a prompt. Here, we can interpolate the parameters that we said before, the user ID and the level. Then we have the user request. We have some parameters that we can give to the advisor. And then we call the model. We go through the whole chain of advisor, and then we output the content as a string to the user. In our case, we don't have only one chat client. We have multiple chat clients. One chat client to contact the model with a lot of advisor, but we have one chat client that is very simple, but do something very important. It make possible to do the function call. In our case, function call is used to retrieve specific information without using the RAG technique. For example, what you can do here is we are defining a function to be called that is the get diary pages, and we can see how to call a function. Okay. What is a function call? A function call is a powerful tool that you can use to call business logic using a model. How you can do that? You give to the model a list of functions with a name, a description, a series of the input of the function and the output of the function, and you give to the model the user request and say to the model, call the best function to answer to the user question. In our case, what we have a function that is called getDocument. This is just an example function that is not used in the real game. And the description says get document by name. So if the user asks to the model, give me the document called 001, for example, we know that this is the right function to call. We give to the model the request. In our case, the input of this function is a file name and a level, and then we say that the output is a string. If the user asks the right question, we are able to not call directly the model, but we are just calling this function from the user request. It's a way to call business logic in an easy way. Okay, here what we have the RAG controller, our ETL pipeline. What we can do, the knowledge that we put in the game is a series of text documents. So doing our ETL pipeline, we are reading this document, we are chunking the document, and then we are adding to the document some metadata. For example, we are adding the level and the type of document. Then we load the document into the vector database using the load function. This function is a two-step function. First, we are sending the document to the embedding model of OpenAI, and we are retrieving the embedding. And then we are storing the document along its embedding into the database in order to be used later with the question advisor that answers to the RAG technique. Okay, so we can go back to the presentation.
Okay. What can be the next steps? well, the first one is not next steps. We started with Llama model on on-premise server, but we had a problem because the size of tokens that Llama model generates was bigger than the vector database columns type. So we have
we were not able to use an hosted model like Llama with our pgvector database.
So we switched back to OpenAI. We'd like to try to use an on-premise model. The second is currently our chatbot game is just a text-based chatbot, but we'd like to exchange images, video, audio with this model. Now you can just chat, but I don't know. Tomorrow it will be possible to retrieve images, a map, or an audio that I don't know, the protagonist of our story leave in a WhatsApp message, whatever. Okay. Then we'd like to put an int system that can help the users that are stuck for a few questions on the same level to try to level up. Yeah. Now it's not possible. Or you do the right questions, or you will stuck
forever,
forever on that level. And Overmind is just a story. It's like one escape room, okay? But we'd like to say, okay, we put a lot of stories on our system, and the user can choose which story to play, okay? The game is the same, but you will play, I don't know, to a pirate story or an horror story.
We can give a different role to the model and a different knowledge, so we can play different game.
Okay.
Okay. Yeah, we have. Thank you for your attention. Here we have a list of documents that we used during the development that spans to from the how to use Spring AI and goes to how to understand vector database. If you have any question, you can ask now, or if you can catch around the conference, we are happy to answer to your question. Any question? Thank you. No question? Nobody was able to terminate Overmind this morning? Or, I don't know, someone reached the third level, at least? No? Nobody? So, you have something to do this afternoon.
Andrea is the author behind the Overmind story.
I wrote a lot of document text, so...
OpenAI, ChatGPT.
Yes.
We also use AI to generate the story, of course.
It's not working.
Just a quick one. Spring AI versus LangChain, what's your preference or like what your recommendation? Which one to choose?
Okay, LangChain, of course. No, well, it depends. LangChain is very well integrated with Quarkus, okay? But the integration that the Spring guys did on Spring is very well.
Yeah, if you are a Spring developer, so you already have an application written using Spring Web, Spring MVC, and you want just to add AI capabilities to the application, Spring AI is the right solution because it's already done for you. You don't need to learn nothing from scratch. But maybe if you want to use different technology, I don't know, Python using LangChain, or you want to use LangChain 4j and Quarkus from using a different application, it's another story. But if you already know Spring and you want to try something, Spring AI is very easy to use. You already know how to interact with the components and the services, and you have a lot of tools to use without write code from scratch every time. It's very fast. We wrote the first POC in a few weeks of Overmind. Then we worked on it a lot, but the first POC was very fast.
Yeah. Spring AI is not officially released. Is the milestone 5?
M5. Yeah.
M5. And every time they release a new version, we had to change our code base so it's not super stable.
Yeah, maybe you can wait for the final release. They say that it will be this year. We hope that this is true, but it's already usable, as you can see. Other question?
Okay.
Okay.
Thank you.
Thank you.